Okay, same title, derivatives of composite functions. And like we talked about before, the derivative of it is derivative of the outside function with the second function inside multiplied by the derivative of the inside function. So with that idea, we're going to tackle this question. And really, without knowing that rule, we could have still probably tackled this question by just knowing our product rule. Okay? Calling this a composite function because we have values inside of brackets, okay? Which is essentially our chain rule. So we're going to have to find, according to our product rule, if I call this my f at x, and I'll rename the function so it doesn't get confusing. Call it h at x. That's our f at x, and this is our g at x. Then h prime x is equal to f prime x times g at x. So the derivative of the first one times the original plus the original of the first one times the derivative of the second. Okay? So with that in mind, we need to derive the very first function. So h prime x is equal to, derivative of this becomes 4. We keep the original 2x plus 3 cubed. And because it's a chain rule, I have to derive what's inside also. So what's inside of this, the derivative of that becomes 2x. Okay? That's only our f prime x. Then we have to multiply by g at x, which leaves this value here, 4x minus 5 cubed. So that whole part here is right here, relatively long. Okay. In our second one, we keep the original, which is x squared plus 3 to the power of 4, and we derive our second function here. Well, our second function, the 3 comes down, so multiplied by 3, 4x minus 5 squared, and then we have to derive what's inside of that. What is inside of that? What would the derivative be? Just the value of 4. Great. So there we go. We've written out the derivative. It's now just some simplifying on our part. So I'm going to take any values like this, 4 and 2x. We'll bring them to the front and multiply them. 4 times 2x will give us 8x. Okay? And then I'll have x squared plus 3 cubed multiplied by 4x minus 5 cubed. And our second part here, we have the value of 3 and 4. We'll put those at the front, so 12. And we have x squared plus 3 to the 4th and 4x minus 5 to the 2nd. This is technically our derivative. A bit long. We can simplify this by common factoring, so we will. We'll go a little farther into this. If you notice, we have x squared plus 3, x squared plus 3, and 4x minus 5, 4x minus 5. Our exponents are the only values that are different. And we always have to go with our lowest exponent when taking a common factor. So we can take 4x minus 5 to the 2nd out of both of these. And we can take x squared plus 3 to the 3rd out of both of these. So those will become our common factors. So I take x squared plus 3 cubed, and I'm going to take 4x minus 5 squared as our common factors. So we've taken those out, which means 8x will still stay. Okay. This value here, when we divide by our common factor, will become just the value of 1. And when we divide by 4x minus 5 squared, our cubed, essentially our exponent just goes to the power of 1. So 4x minus 5 to the power of 1. In our second value, we have 12. When we divide x squared plus 3 to the 4th by the same value but to the 3rd, we just have the power of 1, x squared plus 3. And when we divide 4x minus 5 squared by 4x minus 5, we just get a value of 1. Okay? So these two became our common factors on the outside. X squared plus 3 cubed, 4x minus 5 squared. And on the inside, we're left with 8x times 4x minus 5 plus 12 times x plus 3. I could even go farther, but I just wanted to give you the idea. We could expand and then simplify this bracket, and it does get a little simpler than that. But I think you guys can carry those steps out on your own. Really, the idea I wanted you to get is a composite figure, and this was the derivative. So getting to here is what I want to make sure you guys are able to do. We got time. 4 minutes? Okay. Last type of question. It's the same shit. Here's our last one. Okay? That silly looking thing shouldn't be there. So we have to derive this function. Well, this is a chain rule, right? We have our 10 on the outside. So f prime x is equal to, the 10 comes to the outside. And we have 1 plus x squared over 1 minus x squared to the power of 9. And due to the chain rule, we then have to find a derivative inside. Well, the derivative inside is a quotient, right? And because it's a quotient, we're going to want to use our quotient rule. So I'm going to go through this. If you guys recall, our quotient rule, I'll write it on top, is f prime x times g at x subtract f at x times g prime x, so derivative of the bottom, g at x being our bottom, f at x being our top, all divided by the original g at x squared. Okay. So with that being said, the derivative of the top, if I derived f at x, what value would I get? Yeah, that's right, I'd get 2x. Very good. Then we multiply it by the original on the bottom, so we have 1 minus x squared. Subtract, we take the original from the top, 1 plus x squared. Derivative of the bottom, what would the derivative of the bottom be? That's right, negative 2x. Very good. Okay. And all of that would be above our 1 minus x squared squared again. Okay. So now we've set it up. This is our derivative. They're going to want us to simplify a little. Okay? We'll leave what we have in front, and we'll simplify that second bracket. Squared to the power of 9. Our second bracket here, we're going to expand and simplify. 2x minus 2x, cubed. And then over here, subtract, get it into a bracket, negative 2x minus 2x cubed. Okay. And I'm going to do this all in one shot here. We bring that negative in, and both of these would become positive. Okay? So we have plus, plus. On the bottom here, if we expand this, anyone know what we're going to end up getting? 1 minus x squared times 1 minus x squared. If we were to expand that, okay, we're going to get 1 minus 2x squared plus 4x to the power of 4. So if I rewrite that, it becomes 4x to the 4 minus 2x squared plus 1 on the bottom. We'll simplify the top, and that's as far as I want to go. I think I might be able to factor the bottom and maybe cancel out a little more. This first bracket here, difference of squares, and get rid of the one on top. Yeah, we definitely can, you're right. If we were to do the difference of squares here, this becomes 1 plus x, or 1 minus x, which means we can then take one value out. Can I do that? If I take the squared out? No, because it's 1 plus x squared.
Yeah, so it'll be 1 plus x over 1 minus x.
1 plus x. Let me pause this part for us. Okay, so I made a quick error. I included a 4 that shouldn't have been here. We got rid of it. We cannot factor from up above here. Essentially, this is good enough. We'll simplify the top quickly, but this is simple enough that if we needed an x value to plug in to find the slope of a tangent or velocity or anything like that, I think this is simple enough that we can start plugging in now. So 2x, 2x, these two cancel right out, so we left with 4x over x4 minus 2x squared plus 1. And this would be a relatively, oh, that's the power of 9. This would be our simplified version.